Hi everyone, welcome back. In this video, we're going to continue working through Swift Basics Fun in order to learn some of the basics of Swift. We've already covered a lot of topics, but there are two very important topics that we still haven't covered before we start talking about object-oriented programming. And those two topics are functions and strings. So that's what I want to explain in this video. So let's start in our main.swift file in Swift Basics Fun with a section called functions. So I'm just going to go through a few examples of increasingly complex functions. Let's start with the most simplest. So this will be a function with no parameters and no return value. So we use the func, F-U-N-C, keyword in Swift to declare a function. Then we have the name of our function, open paren, close paren, where we could put our parameter list. And then we could specify our return value, of which we have none. Then we have curly brackets in order to group code statements together that form the body of our function. So this very simple function called say hello is simply going to print out hello. As I said, we were going to start simple. Now I can call this function right after I define it. Okay, I don't actually have to have a specific main function in main.swift. Main.swift is a special file where you can have code outside of functions. But in any other Swift file, they actually have to be inside functions. Okay, so executable code has to be inside functions unless you're in main.swift. All right, so I'm going to call say hello, and we should see hello show up. And there it is. I think while I'm here, I'm just going to go ahead and comment out my please enter your favorite season, just so I don't have to keep typing that in each time. Perfect. There's hello. All right. Now let's bump things up a little bit in terms of our complexity scale. Let's do one parameter, no return value. So I'm going to declare a function called say, and it's going to be like say hello, but it's going to be parameterized to accept the string in which to say. So this string is going to be the message of the function, okay? So my function is going to be like say message. So message is going to be the name of my parameter of type string, and I'm going to print out message. Let me take some notes on what I just did here. So message is the name of the parameter, okay? You're familiar with this from other programming languages where you have to declare a local variable called a parameter to store an incoming argument. So in Swift, this particular use of the parameter name message is an example of an internal parameter name, okay? An internal parameter name. Message is to be used inside of the say function. Now, because I haven't specified an external parameter name, right? If there's an internal parameter name, there's probably an external parameter name. Because I haven't specified an external parameter name, then the internal name is also the external name, which is also known as the argument label. Let me write this down because it's so important. Okay, this is important because when I go to call this function, I'm going to have to specify the external parameter name message when I pass in an argument for the say function to display. So I'm going to call say. You'll see I've got two matches here so far. I want say message, in which case I have to specify the external parameter name message and then provide some sort of value to this parameterized function, which this one I'll just do say hola. All right, so now we've got our output. We see hello from line 146, and we see hola from line 159. So why is this like this? Well, by convention, Swift has you name functions and external parameters to form an English sentence. So if I read 159, it says say message. So both the external name and the function name together form a sentence. And that sentence is what uniquely identifies the function, not just the function name, which is really interesting. When we talk about function overloading, I'll elaborate on this a bit. Okay, let's complicate things a little bit more. Let's do a little task here where we're going to write a function to compute the area of a circle. A very basic task. We're going to have with radius be the external parameter name. Then we're going to have just radius be the internal parameter name. So I've got my function compute circle area. Okay, this is a verb, right? It's an action. It's going to do something. And it's going to operate on a noun, okay? Some sort of object, some sort of item. So it's going to compute circle area with radius, okay? This is the external parameter name. Radius is going to be the internal parameter name, and it's of type double. Let me do my quick little computation here. Okay, so to fully identify this function, the name is compute circle area with radius. Let me show you how you call this. Compute circle area with radius, maybe I'll pass in 5.0. Do you see how this reads as an English statement? Okay, compute circle area with radius. Okay, let's take a few more notes related to these parameters. So first off, parameters are let variables, which means they are read-only. Secondly, you don't have to specify an external parameter name. So if you don't want to do this, then you can instead use an anonymous variable, which is an underscore. And I'll show you an example of this. All right, so let's do our compute circle area function again. But this time, instead of using with radius, which is the external parameter name, I'm going to replace it with an underscore, which means that now when I call compute circle area, I don't have to specify a parameter name or argument label at all, okay? I did here, but on this call to my function, compute circle area, I'm going to pass in a value, say 4.0. Let me name this a different function. And I don't have to put on that external parameter name because I'm kind of suppressing externalization here. So this radius name is not going to be known to the caller of this function unless perhaps they look up the source code or they look up the documentation and it's listed there. All right, now let's dive into whether values are passed by value or by reference in Swift, because this is a really important topic. So first off, unless you are passing an object of type class, so that means not a struct and not an enum, then all arguments are passed by value. Okay, this is really important. So for example, what we think of as primitive types like ints, doubles, floats, etc., these are types of structs, not types of classes. Therefore, they're going to be passed in by value, not by reference. Okay, if you have a type that is an object of a class, then that object will be passed by reference. And we're going to talk more about the differences between structs and classes when we talk about object-oriented programming in Swift. But for now, just know that if you're passing an object, it's going to be passed by value unless it's a type class. All right. So let's declare a parameter as in-out to make it pass by reference. So if I have a pass by value type, I can force it to be passed by reference by declaring the parameter as in-out and using the ampersand in a somewhat similar fashion as you might know it from C or C++ as a reference variable or the address of operator. All right, so let's have a function called increment, and it's going to have, if I can type here, it's going to have a parameter called value, which is of type in-out-int, which means this value, when changed in this function, is going to have its change persist because it's going to be passed in by reference. And then I'm going to have another parameter. This one's going to have an external and an internal parameter, right? Parameter name. This one, because I only specified one name, is both an internal and external parameter name by an increment value of type int. And all this little function is going to do is assign to that in and out variable that variable's value plus increment value. That's it. Okay, so this is really important, this demo right here. Let's declare a variable, we'll call it y since I already have an x. Y is assigned 5. I'm going to call increment and I'm going to pass in y by reference and then by, let's say, 10. So I'm going to print out y right here. And because y is going to be passed by reference, when I add 10 to the value of value, that change is actually going to persist to the y variable. I'm going to get 5 plus 10 is 15 and overwrite the value referenced by value, which is y, to 15. And we'll see line 190 is going to print out 15. Okay? So let me just recap what we just did here. If you have a pass by value type, okay, which means you have an object of type struct or enum, not of type class, but you want to pass that in by reference because this function needs to go to that location in memory and change its value, then you can specify that parameter to be in-out, which is essentially saying this is a passed by reference parameter. When you call the function, your argument needs to have the ampersand on it. Changes made in this function to an in-out parameter are going to persist to whatever was passed by reference in the calling code. All right, that is a brief overview of functions in Swift with the external versus internal parameter names, with the anonymous variable name, and with the in-out passed by reference. There is a lot to take in. But as we know, functions are building blocks of code, so we're going to get a lot of practice working with functions before we move on to too much crazy stuff in Swift or iOS programming. All right, the last thing I want to talk about in this video is related to strings. Strings in Swift are both cool and a little bit annoying, but that's because they're so powerful. So let's add a section to our Swift Basics Fun called strings. So what we're going to cover related to strings is actually some specifics about the string type and the character type. So a string, and note the capital S on string, I'm actually talking about the type here, is a sequence of characters. And notice the capital C on character, I'm talking about the actual character type. A character is one or more Unicodes, and I'm actually talking about the type Unicodes here. So this is kind of crazy. There are over 130,000 plus Unicode values. That's an entire character set. And Swift is fully Unicode compliant, which is really cool. So let me show you why this is so cool. Here's some basics of strings. So I could have a variable, let's call it unicorn, and it's going to store the string unicorn. Great. But we live in an emoji-based world, right? Well, emojis are Unicode values. So instead of having the word unicorn, I could actually put a unicorn emoji in here. So if I do Control Command Spacebar, this is going to bring up the character viewer where I can search for characters, Unicode characters, including emoji. So let's say I search for unicorn. There's the unicorn right there. Double click on it, and I can actually have a unicorn emoji in my code, which is really cool. Okay, taking this one step further, I could actually have emoji or any Unicode value in my variable name. So I could declare a variable, and I will call this variable, let's do the dinosaur emoji. So Control, Command, Spacebar. Let's do the dinosaur, this guy. So my variable is actually called this dinosaur emoji. And perhaps I'll just put dino in here. Maybe I'll print out my unicorn. And maybe I'll also print out my dino. Okay, so the first one's going to give me an emoji. The second one's going to give me the string characters DINO right there. So that's pretty cool. That's kind of fun. Okay, let's not get too carried away with emoji. Let's kind of get back to the basics of working with strings in Swift. All right, so we have a lot of the basic operators that you're used to from other languages. So we have string concatenation. So this is the plus sign. Relational operators, so less than, greater than, less than or equal to, etc. Here are your equality operators in Swift. So you've got two equal signs for character by character equality, Unicode by Unicode equality, and the not equal sign for inequality. Some important properties or ways to work with strings include the count property. In fact, we saw that in a video I made a few videos ago where we were printing out the characters in our name, or the number of characters in our name. Here's one really tricky thing about working with strings in Swift. Because they are fully Unicode compliant, indexing with strings in Swift is what I would call the annoying part. It's not as simple as just using an integer index to grab a character that you want at a position you're interested in. So let me write that because it's so important. You cannot index into a string using the subscript notation brackets and an integer. So you instead need to use a string.index object. So let me go through an example. Let's say your course name is CPSC 315. Okay, or you just have some course prefix and then some numbers here. So I have 4 letters of my course prefix and then 3 letters or 3 numbers for my course number. All right. So let's say I want to print out the first letter in this string. I can't do course sub 0. That would be so nice if we could do it. It just won't work. Build failed. Instead, what I have to do is get this string.index object, which I can get from course.startIndex, which is a property right there. See the V? It's a variable of this string object, which start index is of type string.index, which is what I need. So this is going to give me the capital C of CPSC 315. All right, so there's the C right there. Okay, that wasn't so bad, but it's going to get a little uglier. So let's say we want to print the 3. So 0, 1, 2, 3, 4. Okay, so this is that index position 4. So let's write this out really verbosely. Let's have a variable called index of 4th character is assigned course.index, okay, where I can specify, so this is overloaded, I can specify some starting indexes and some offsets or afters or befores. So we're going to do the one with the start index and an offset by. So I'm going to pass in course.startIndex, okay, which we know is 0. And then we're going to have offset by 4. So we're going to offset 4 from the start index, which is 0. And now I can simply use that string.index object to index into course. And that will give me the 3. There's the 3 right there. All right, so something fun to try related to strings, just to see how it feels to start working with these string.index objects. I've got a little task for you here. I believe this is task 3. So write and call a function that accepts 2 strings and returns true if their last characters are the same. So here's going to be an example. So Gonzaga zebra would return true because they both have A as their last character, regardless of their length. But Gonzaga summer would return false, okay, because the last letter of the first string is A and the last letter of the second string is R. So go ahead and try this out. You're going to have to explore a little bit with the index method, but see if you can take a stab at it. All right, let's go through this. So we're going to declare a function called something like same last character, and it's up to you what you want to do with your parameters. I'm just going to suppress externalization and use the anonymous variable name. And then internally, I'll have string 1 of type string and string 2 of type string. And here, I'm going to return a bool. Here, I'm going to return a bool. Okay, so we have our arrow to indicate we're going to specify our return type, and our return type is bool. All right, and here, I'm going to get an index, a string.index object for the last index of each string, and then I will compare using character equality and those two string.index objects. So last index of string 1 is going to be string1.index, and I'm going to grab the index of the character before string1.endIndex. Now I could do the same thing for my second string. Just replace string 1 with string 2. Now I can simply use these 2 indexes to index into my strings and the equality operator to compare 2 characters. Now let's call this function and we'll test it with those 2 test cases that I provided. So we'll do Gonzaga and zebra. And we'll also do Gonzaga and summer. So the first one should be true and the second one should be false. And there we have it. So like I said, working with strings is kind of fun because of all the Unicode support, but because of that, it's also just a little bit of extra work to have to figure out, okay, how do I get a string.index for the index of the character that I want? But with some practice and some exploration of the available documentation for strings and string.index, you should be good to go. All right, well, that was a video introducing functions. We went through a lot. So we talked about internal, external parameter names, differentiating an internal versus an external parameter name, the anonymous variable name, which is the underscore. We talked about passing by reference, using an out, and then towards the end, we saw an example of returning a value. All right, that's it. Thanks for watching.